Welcome back, students. This is the session 4 from the chapter of current electricity. The topic is resistivity versus resistance. So in this session I will be giving you or I will be telling you about the basic difference between resistivity and resistance. So here I have written a few points on this board. The first point is I have defined the this resistance. So the resistance of a conductor is a measure of opposition offered by it to the flow of the current. So everybody knows about this definition, so it doesn't need to be elaborated too much. And its SI unit is ohms. And second point is, this is the important point. The resistance of a conductor is dependent on the material of the conductor. It also depends on the temperature, pressure, and the dimensions of the conductor. Here, this was the relation which we have derived in the session number 3. That is, the resistance of a conductor is equal to resistivity multiplied by the length of the conductor divided by the area of cross section. So from this formula we can see that if the area of the conductor is increasing, keeping the length constant, then the resistance will decrease. Similarly, if the length of the conductor is increased, keeping the area constant, then the resistance will increase. Now, from this relation, that is V is equal to IR, what I have done is I have substituted the value of this resistance in this equation. That is, in this equation, that is V is equal to IR. So R is equal to rho L upon A. So I substitute this equation in V is equal to IR. And we have already discussed about all these equations in this session number 3. So it is just a revision. So V will be equal to I rho L upon A. So now, since I upon A is the current density, that is the current per unit area, so and current density is denoted by J, so J rho L. Now, if E is the intensity of the electric field in the conductor of length L, then V will be equal to E into L, and so I have substituted the value of V as E into L, and this is equal to I rho L upon A. So from this equation we get that E is equal to rho I upon A, or it can be written as E is equal to rho into J. J is the current density and rho is what? It is the resistivity of the conductor. Now, since the conductivity of the conductors, that is sigma, is the reciprocal of the resistivity, therefore E is also equal to J upon sigma, where sigma is the conductivity of the conductor. Now, the resistance of a conductor is dependent on temperature and pressure. That is, when the temperature increases, the resistance will increase, and when the pressure increases, then the resistance will decrease. Now, let's come to the second point, that is resistivity. Now, the resistivity of a conductor, it is also a measure of the opposition offered by the conductor to the flow of the current. And the relation between this resistivity and this resistance is given by this formula. This is the formula, that is R is equal to rho L upon A. But here the most important thing which we have to remember is that in this resistivity does not depend on the dimensions of the conductor. It depends on the temperature, pressure, and the material of the conductor. It does not depend on the dimensions of the conductor. Resistance depends on the material of the conductor, temperature, pressure, and also on the dimensions of the conductor, that is the length of the conductor and the area of cross section. Whereas resistivity does not depend on the dimensions of the conductor. It only depends on the temperature, pressure, and the material of the conductor. Here I have already written here that resistivity is inversely proportional to pressure. That is, when pressure increases, resistivity decreases. and when the temperature increases, resistivity increases. Similarly, here also in this case, in the case of resistance, when the temperature increases, resistance increases, and when the this pressure increases, the resistance decreases. Another important thing, when the area of cross section of the conductor increases, keeping the length constant, then the resistance will decrease. And if the length of the conductor is increased, keeping the area of the conductor same, then in that case the resistance will increase. So the basic difference between the resistance and the resistivity is that the resistivity does not depend on the dimensions of the conductor, whereas the resistance depends on the dimensions of the conductor, as well as it also depends on the material of the conductor, temperature and pressure. Resistivity only depends on the temperature, pressure and the material of the conductor. It does not depend on the dimension of the conductor. So this was the basic difference between the resistivity and the resistance of a conductor. So in the next session, I will be now coming up with a couple of questions based on what we have studied in the session number 2, 3 and 4. So till then, have a nice day. Bye.